time for problem number 3. So now they give us functions and we're explicitly asked to find the inverse function. So now we're going to test that skill with this problem. So let's go ahead and work that out. All right. So number 3, yeah, like this. So what do we have? We want to find the inverse. The first function is f of x equal to 3x plus 4. So there are two ways to kind of think about this. So I'm going to call this y. And you can think of this in two ways. It's really the same thing. So the way I tend to do it is I solve for x and then switch what x and y are at the end. So let's try it that way first. So y minus 4 would be equal to 3x, subtract 4 from both sides. Or y minus 4 over 3 is equal to x. And now here's where I'm going to switch the roles of x and y. So y equals x minus 4 over 3. And when I say switch the roles of x and y, all I mean is anywhere I see a y, replace it with an x. Anywhere I see an x, replace it with a y. So that's one way to do it. And these two ways are pretty much the exact same thing. But that's one way. The other way is to just replace x and y at the start. So g of x I'm going to call y again, equals x squared on 1 comma 16. Again, it couldn't be all real numbers or else we wouldn't have an inverse function. But because these numbers are all positive, it's not going to be an issue. So here your other option is start out switching x and y. So x equals y squared, and then solve for y from there. So for example, square root gives you y is equal to the square root of x. And we don't need a minus sign here because we are taking square root and our domain here is positive. So I just want to note, if the domain was minus 1, say minus 16 to minus 1, then what we would have had at the end would have been y equals minus root x, because we want to make sure the number we get actually lands in the right place. So just a note there. Okay. And then finally, h of x. H of x, which I'll once again call y, which is equal to e to the x on 0, 1. Domains of the inverse functions, I forgot to say that. Okay. We'll come back to that. So h of x equals y equals e to the x. Take natural log of both sides, you get natural log of y is natural log of e to the x. But natural log and e cancel. So we're left with natural log of y equals x. Replace x and y. So natural log of x is equal to y. And then what's the domain of the inverse function? It's going to be the range of the original. So this range of h of x, let's see. So we know e to the x is increasing. So therefore we're going to get e to the 0, comma e to the 1. I want to be very explicit about something we're using here. Using e to the x increasing. Because e of 0 is like the smallest thing you would see. E of 1 is the biggest thing you could see. This isn't true in general. So this is 1, comma e. So domain 1, comma e for that one. For this one, again, what's the range? This is another increasing function, so the range goes from square root of 1 to square root of 16, or from 1 to 4, which means this guy has domain 1 to 4. And then finally, we're going to use the same exact trick. Range, let's see. Okay, so this one's easier. Because it's from minus infinity to infinity, the range is also minus infinity to infinity. So the domain is also minus infinity to infinity. So that one's fairly simple. All right, so that's number 3.